AS-Level Trigonometry Exam Preparation Questions Part 4. Let's look at another example. Show that the equation tan x plus sin x over tan x minus sin x equals k, where k is a constant, may be expressed as 1 plus cos x, 1 minus cos x equals k. Let's start. Let's start with the left-hand side. Okay. Now, not the easiest, maybe the long, but usually if you don't know what to do, break up everything into sin and cos. So tan x will be sin x over cos x. Make this a fraction by saying sin x over 1. The same. Sin x over cos x minus sin x over 1. Then make the denominators the same. So I must make both cos x. So I multiply cos x, I multiply cos x. Multiply cos x, multiply cos x. So I'm getting sin x plus sin x cos x over cos x. The same here. Sin x minus sin x over cos x. Now, if I have a fraction over a fraction, I multiply with the reciprocal of this one. So the cos x cancel out. Now, if I take out sin x there, I will have sin x 1 plus cos x. If I take out sin x here, I will have 1 minus cos x. The sin x cancel, and then I can see it's expressed as they said there. Did you see that? Okay. Now, hence express cos x in terms of k. Now, if I have that this is equal to k, so basically I'm just taking this and I'm going to get rid of the fraction, so I'm going to cross multiply. So I say 1 plus cos x and then k 1 minus cos x. Okay, so now let's just move it up. I'm going to say, okay, so I'm just going to multiply in that. Can I just show you? I multiply, I get this. Now take all if I'm looking, I want to express it in terms of k. So let's just see if I'm going to check at this one. I just want to hence express cos x. Okay, so I must make cos x the subject. Okay, this is why I was checking again. So take your terms with cos x. Do you see it? There is a cos x, there is a cos x. And I'm taking it to the same side. So that's why I take that one over. Okay, so then I'm taking this one over there. Then I take out cos x as a common factor. So it's 1 plus k. And now I divide by 1 plus k, 1 plus k, and I'm ending up with this. And this is my final answer. Okay. And then hence solve the equation equals 4. Now basically I can then just say that if this is equal to 4, then this will be equal to 4. This cos, because if I go back, I could have said, do you see? Because this was equal to k and this was equal to k. Did you see? So I can basically just go and substitute that in the place of that. And that's what I did there. Can you see? So if this is equal, then this is equal to 4. Okay. And if this is equal to this, then I substitute it further. Did you see there? And I'm going to say, okay, so, and then I'm going to say k minus 1 is equal to, and I'm putting that value of k. Did you see? I'm putting it in. So I'm going to say cos x equals k minus 1, 1 plus k. I have the k. The k is 4. So I put it in. 4 minus 1, 1 plus 4, and I get 3 over 5. So basically, I'm just getting cos x equals 3 over 5. Now, where is cos positive? Oh, then don't forget also my domain. My domain is x is negative 90 positive. So this is scratching out. Did you see? And then it's the positive and the negative. Okay, but where is cos? Cos is positive in the first and in the fourth. So it's in there. but I go for the positive, so press on your calculator. So press shift cos, make sure it's on degrees. So shift cos bracket 3 divide 5, close the bracket, equals. And the key angle, I can write it down here, or the base angle, and that is going to be 53.13 degrees. So if it's to this side, it's positive 53.1, and if it's to this negative, it's negative 53.1 degrees. Very interesting question. I would say my suggestion will be that you cover the answer, that you, before you start with the exercise, that you just don't look at my answer and try to do it 100% on your own and see if you come to the solution that I showed you there, because it's a brilliant exam example. Okay, I want you to stop the video and I want you to try now for just number 1 first. As soon as you finish with number 1, you can continue the video and check if you are correct. Okay, so let's start with question number 1. Number 1a. Solve the equation. So it's a nice quadratic one. So it's going to be 3 tan square x minus 5 tan x minus 2 is equal to 0. Okay, always look at your domain. It's between, I just want to write it out. Okay, so if I'm going to make a sketch here, I'm just going to say it's going to scratch out that part. Okay, but let's factorize first. So if I factorize, so let's make it 3 and 1 and 2 and 1, because 6, it's in group B. 6 minus 1 is 5, and the biggest over cross product get a negative, and this one get a positive. And then if I write it, I'm going to say 3 tan x plus 1, and then tan x minus 2, and that is going to be equal to 0. Okay, so I break it up. So it's 3 tan x plus 1 equals 0, or tan x is equal to 2. Okay, so then this one is going to be tan x equals, okay, so if I take it over, it's negative 1, and if I divide, it's 3, so it's negative a third, and that one, I'm just rewriting it, tan x is equal to 2. Okay, now because tan, sin and cos cannot go up above the normal 1 or negative 1, but tan can. Just think of the graph. Can you remember the graph of tan? It goes up. Okay, so it can. So in this case, so let's do this one for this one. I'm going to first get my base angle. So let's quickly get our base angle. I'm going to say shift, put it on degrees. So shift tan and then 2, and I'm getting my base angle was 63.43, always 2 decimal places for the base angle to go to an accuracy of 1 decimal place, 43. So I'm just thinking, where is tan positive? It can only be there because this one is blocked out. So I can already say that x is 63.4 degrees. That's for that one. And if I make a sketch for this one on this side, here I block out again. But now where is tan negative? So tan is going to be only negative there because there it's positive. So again, get my base angle. So don't press in the negative, just press shift, press tan, press bracket, 1 divide 3, close the bracket, equals, and I get it's 18.43. Okay, so that one is 18.43, but remember I'm working from there. So I is going to say that x is equal to 180 minus 18.43. And if I'm doing that, I'm going to get 161.6 degrees. So therefore, what is my two angles? X can be 161.6 degrees or X can be 63.4 degrees. That is my final answer. Okay, let's go to number B. So that was a very nice, very straightforward, very nice question. I will say in level 1. Okay, number B. Find the set of values of k for which the equation, this equation, has no solutions. Okay, so it's back to chapter 1, nature of the roots. So if I take the equation 3 tan square x, and remember, they like to to act with other chapters also, to cross to other chapters. So go back in your brain to chapter 1. When will it have no real roots? When the discriminant is smaller than 0. Okay, so don't forget, if I'm going to do, what is the discriminant? It's b squared minus 4ac, and that's smaller than 0. Okay, so don't forget that then this is going to be my c, and this is going to be, always grab the sign also, this is going to be my b, and this is going to be my a. Okay, so if I'm going to say, I start with b, so it's b squared, so let's just say, so it's going to be negative 5 tan x squared minus 4, what is a? It's 3 tan square x, and and c is k, and that's smaller than 0. Okay, and if I work it out, if I multiply, I get 25. A negative times a negative is a positive. So tan square x minus 12 tan square x, and bring in your k, and it's smaller than 0. Okay, so let's see if I can take that over. So I have 25 tan square x, and if I take it over, I get 12 tan square x k. But now I see, oh, this is nice. I can divide by, doesn't matter which side I'm dividing. Let's see, oh, yes, I want to rather with a k. So I divide 12 tan square x. I divide 12 tan square x. So then I say k is bigger because this cancel, and I have 25 over 12. And if I want to turn it around, then I say k is bigger than 25 over 12. And that. So don't be confused if they bring in a k, a constant, if they bring in nature of roots. Just take your memory back and just bring that knowledge into trigonometry. Okay. And then now the last one will be number C. In this question. Okay, so let's go to number C. For the equation this, state the value of k for which there are free solutions in the interval and find these solutions. Okay, now I did a little bit of a trial. I made k is equal to 0. Okay, because as soon as I make k equal, let's try, I make a statement. If k is 0, so let's say if k is 0, then I can go and I can say, okay, so let's just bring in the equation 3. I'm first going to write it out. Tan x plus k, okay, let's just see, okay, plus k. Okay, so if I make it 0, then it's going to be, so if k is 0, then 3 tan square x minus 5 tan x plus 0, equals 0. But I'm ending with, and this is what I want. I want just to end with this. Okay, now let's go and I take tan x as a common factor. Then I have 3 tan x minus 5. Are you with me? Equals 0. So I have 2. I have tan x, I break it up, equals 0. Or I have 3 tan x minus 5 equals 0. So 3 tan x equals 5. So tan x equals 5 over 3. Okay, now let's go back to my graph. Let's go just to my graph. Okay, I'm just going to make 2. So let's see how I'm going to handle this too. Okay, so if I go to my graph, I know where is tan 0. So always just reflect on your sketch. So it's always there. Oh, I made it too short. Okay, let's just make it longer here. Okay, it's a bit. Okay, so how is your tan graph looking? Your tan graph is looking always like this. So it's like this, and it's like this, and it's then, okay. So basically, because let's just see, it's only to 180. So it's only up to here to pi. Now, where is it 0? Let's just see if it's included. Yes, because it's going to be there and there. So I can say that x equals 0 degree or x equals 180 degrees. Do you see that? And now this one, where is tan positive? Now remember this is blocked because it's only up to 180. So then tan will be only positive there. But if you go and you say shift tan bracket 5 divided by 3, so what will be your base angle or your key angle? That will be 59.04. So I can in one decimal place, or I can say x is 59.0 degrees. Put that 0. So hence, so what did they say? For oh, sorry, I marked the incorrect one there, but it was also 180, luckily. So for k, there are 3 solutions in the interval, and find these solutions. So I made k 0 and the 3 solutions. This was my 3 solutions. Okay, I want you to stop the video again, and I want you to try number 2. Okay, let's start with number 2. Okay, let's make it 2a. Prove the identity. Okay, so let's first write it out. So 1 minus 2 sin square theta over 1 minus sin square theta. Identity is 1 minus tan square theta. Okay, so the first thing. Now, if we're going to prove, so just go to the left-hand side. So if I'm going to start with that hand side, I'm first going to do this one. Can you see? Can you remember? Because sin square x plus cos square x is equal to 1. So 1 minus sin square is equal to cos square x. Do you see that? So I'm going to say 1 minus 2 sin square theta, and I'm going to substitute there cos square theta. Okay, now I'm going to break this further up. Now I'm going to, because this is a fraction, I can write it over the denominator, and I can put that one also, that other, because there's 2 on top, over the denominator. It's almost like the reverse if you're making the denominators the same. I'm just break. So usually we work from this step to this, but now I'm just doing the reverse. Okay, so what do I get? Now here I take the third, it's sec, so it's sec square theta minus 2, a sin over cos, so it's going to be sin square, just the square is a little bit, so it's tan square theta. Okay, now I want to take you back. I want to take you, and you must just know your 3 basic in this chapter. So if I take you back, can you remember this identity? Okay, make it bigger. I'm going to use this one now. So tan square theta plus 1 is equal to sec square theta. Okay, so in the place of the sec square theta, I'm going to substitute now that. So let's just go back. Okay, so can you remember? So I'm going to, in the place of this one, I'm just going to put now tan square theta plus 1 minus 2 tan square theta. So what will I get? I will get 1, put the 1, minus tan square theta. And then I can say the left-hand side is equal to the right-hand side. And that's how I can end. I was putting this example in because it was for me, it's just a nice proving of the identity. And I wanted you to also see, because as soon as the more proof of identities you do, the easier it is to recognize a certain type in the exam. So practice that a lot. Okay, but that was question number A. Now you will use that in question number B. Now I usually write it out very nice, but for now I'm just going to show you. So Hinch solved the equation. Now I usually show you if this is the same, if this is equal to this and this is equal to this, then it just shows you that you can start with the statement. So I usually say, if I write it out nice, I say, if this is equal to this and this is equal to this, then, and I start and I say, then 1 minus tan square theta is equal to 2 tan to the 4 theta. Okay, and now I take everything to one side, so I'm going to say 2 tan 4 theta plus tan square theta, and then I'm bringing the 1 over, so minus 1 and that. Okay, so it's still a quadratic equation. It's just, because it's double, do you see? So I can basically still say it's 1 and 1 and 2 and 1. It's still in group B. So 2 minus 1 will be that 1. That is all right. And just remember that I take this middle one. So tan square theta. Tan square theta. Oh, and the biggest over cross product gets a positive and this a negative. Okay. But if I write it nice, I'm going to say, okay, 2 tan square theta minus 1 and tan square theta plus 1. Okay, that's what I'm going to get. Then I put the 2, so I say 2 tan square theta minus 1 equals 0, or tan square theta plus 1 equals 0. So 2 tan square theta is equal to 1. So I divide 2, I divide 2. So tan square theta is equal to a half. Okay. Or I can say tan square theta, this is a problem because now I cannot take the square root. I cannot take the square root of a negative, so I just say not applicable. That one stops. This one goes on. So now I can take the square root of plus minus a half. So tan theta equals plus square root a half, or tan theta equals negative square root a half. Okay, and basically I'm just going to make two cos diagrams. Let's just quickly do that. This is my one, this is my other one, and again, can you remember, it's only 0 to 180, so I'm blocking out, okay, and then I say, okay, so how do I press on my calculator? Make sure it's on degrees, so shift tan, and then press first the square root, then the bracket, and then 1 divide 2, close the bracket, equals. And the key angle here, we can just write it, key angle, or the base angle, is 35.26. Make 2 decimal places for the key angle. Okay. And for this one, okay, I'm just going to do the same now. Say this one's key angle. I could have first finished one off. But then I can go shift, and then I'm going tan. And then I go square root. Oh, negative. So shift, tan, negative outside. Then square root. Then, no. We never press in a negative. Sorry. So it's going to give you exactly the same. It's because we don't press in the square root. Are you with me? So we just say, where is tan negative? Tan is negative there. Where is tan positive? Tan is positive there. Okay, so please correct that. The base angles will be the same due to the fact that we don't press in that. But now we go and we say theta, theta is going to be just the 35.3 degrees in this one. And in this one, theta is going to be 180 minus 35.26. And if I simplify that, 144.7 degrees. So, therefore, okay, theta is 35.3 degrees, or theta is 144.7 degrees. And that is the final answer. I want to end this video with 3 points. Point 1. All these videos refer to the y equals mx+c textbooks, the number 1 mathematics textbook used in Namibian schools. For more information on these textbooks, visit the Straight Line Publishing website. Point 2. All y equals mx+c to success textbooks are available in the NEET catalogue of the Ministry of Education. Schools can order these using their yearly budget for textbooks, with the process typically starting mid-year. Make sure your learners have a copy of the y equals mx+c mathematics textbook used by the top schools in Namibia in front of them in 2025. A final point. If you are in the position, I want to encourage you to buy your own personal copy of the y equals mx+c mathematics textbook. These textbooks are available at the following bookshops. Remember, success in mathematics comes from hard work, perseverance, and the courage to face challenges head on.